Welcome to This Explainer. Today we're tackling a topic you literally cannot escape right now, artificial intelligence. From generating mind-blowing art to writing complex code and even predicting biological structures, it really feels like AI just suddenly arrived out of nowhere to change our world.
But wait a second. Before we get totally swept up in all this modern hype, we really have to ask ourselves, is artificial intelligence actually a sudden, magical invention of our current century? Because honestly, when you hear the term AI today, your mind probably jumps straight to the 2020s. But the roots of this whole thing, they go way, way further back than most people realize. So to map out this 80-year journey, we are going to explore 5 distinct eras. We've got the birth of AI, the freezing AI winters, the massive machine learning comeback, the deep learning revolution, and finally, today's generative AI explosion. Let's get right into it. Section 1, the birth of artificial intelligence and setting those crucial theoretical foundations. We're winding the clock all the way back to the 1940s and 50s. Now, this was a deeply deliberate and theoretical era where the literal bedrock of machine intelligence was being poured. It all kicked off in 1943 when Warren McCulloch and Walter Pitts modeled a simplified artificial neuron using propositional logic. Mind-blowing for the 40s, right? Then, jump to 1950, Alan Turing drops his famous paper introducing the Turing Test to actually evaluate machine intelligence. All of this incredible groundwork was building up to one pivotal summer gathering in 1956. And right at the center of that gathering was this guy, John McCarthy, a brilliant researcher who brought together the era's top minds. And they shared this deeply optimistic, maybe even slightly naive belief that literally every single aspect of learning or any other feature of intelligence could be precisely described and then simulated by a machine. In fact, in the official 1955 proposal document for that Dartmouth Conference, McCarthy actually coined the term artificial intelligence. Get this, they genuinely believed that a 2-month, 10-man study could yield significant advances in making machines use language and form abstractions. I mean, talk about ambitious. Which brings us to Section 2, High Hopes and AI Winters, or the cold reality of hardware. So, those early theoretical wins, they created massive, massive hype. But as we roll into the 1960s and 70s, researchers hit an absolute brick wall of computational limitations. To put the scale of the problem into perspective, think about Marvin Minsky. He built the very first neural network computer in 1950, called the SNARC. It needed 3,000 physical vacuum tubes and an automatic pilot mechanism just to simulate a tiny network of 40 neurons. The hardware simply couldn't cash the checks the theory was writing, and that led to a crushing period of disillusionment that we now call the AI winter. And honestly, it wasn't just one winter. There were multiple deep freezes of funding cuts, interrupted by brief thaws of optimism. From 1969 to 1980, the first winter hit hard, because early AI couldn't even handle basic logic puzzles. Then we saw a brief boom in the 1980s with expert systems that tried to mimic human reasoning. But, you guessed it, those rigid rule-based systems were just too brittle for messy, complex, real-world problems. That dragged the whole field, kicking and screaming, right into a second AI winter from 1987 to 1997. All right, moving to Section 3, the machine learning comeback and a massive shift in strategy. Because AI definitely wasn't dead. In the 1990s, the field finally stopped isolating itself. Instead of fighting with disciplines like statistics and control theory, AI embraced them, and that kicked off the machine learning comeback. This was a complete game changer. Instead of painstakingly trying to hand code every single rigid rule, researchers flipped the script. They started building systems that used probabilistic reasoning to actually learn from massive amounts of data on their own. And this huge shift, it yielded a world-shocking milestone in 1997. In May of 1997, IBM's Deep Blue defeated the human world chess champion, Garry Kasparov. You have to understand, this was a total watershed moment. It loudly signaled to the entire world that AI was back, it could outcalculate the greatest human minds in constrained environments, and it was significantly more powerful than ever before. Next up, Section 4, the deep learning revolution, where data and compute finally collide. As we hit the 2010s, the pacing of innovation doesn't just speed up, it goes absolutely exponential. Why? because massive data sets and the sudden rise of super powerful gaming GPUs completely fueled the deep learning revolution. These deep learning systems finally fulfilled the wild promises of those 1940s neural networks because suddenly we actually had the computational scale to train them. We literally went from struggling with clunky vacuum tubes to using highly specialized hardware capable of performing hundreds of trillions of operations every single second. It is wild. And the milestones just started flying by. In 2011, IBM's Watson wins the quiz show Jeopardy, showing off some incredible natural language processing. Then in 2012, Jeffrey Hinton's group totally crushes the ImageNet visual recognition competition using deep learning, practically proving overnight that big data beats handcrafted models. And then, 2016, DeepMind's AlphaGo defeats human champion Lee Sedol in the ancient game of Go, a game so infinitely complex, experts thought this feat was decades away. Which brings us to Section 5, the Generative AI Explosion, our brand new era. So let's look at the explosion of the late 2010s leading right up to today. This is where AI evolves from just categorizing data to actually creating it. A monumental breakthrough dropped in 2017 with the Google publication of the Transformer architecture and its attention module. This fundamentally rewired natural language processing. It gave machines the ability to understand long-range context in human language, birthing the foundational models we know today, like BERT and the entire GPT series. But listen, it is not just text or clever chatbots. This tech is driving profound, real-world scientific discovery. Take the number 170,000. That is the exact number of known protein structures that human scientists had painstakingly mapped out over decades of grueling lab work. Well, DeepMind took those 170,000 known structures and fed them into an AI called AlphaFold. By learning the hidden patterns in that data, AlphaFold practically solved a 50-year-old grand challenge in biology overnight, accurately predicting the 3D shapes of molecular machines. It was a breakthrough so massive it literally earned its creators a Nobel Prize. It proved, beyond a shadow of a doubt, that AI can drive human scientific discovery at light speed. And that brings us to where we are today. Looking at the recent Gartner hype cycle, generative AI is sitting right up there at the peak of inflated expectations. It absolutely echoes the massive hype cycles we saw back in the 50s and the 80s. But there is one absolutely critical difference this time around. We actually have the undeniably powerful modern tools, the immense data sets, and the raw computational firepower to back it up. Which leaves us with this final, massive question. If we have come this incredibly far since that first mathematical model of a single neuron back in 1943, what unimaginable breakthroughs, or perhaps totally unforeseen winters, await us in the next 80 years? I really hope this explainer helped map out the immense history behind all the modern headlines. Thanks so much for exploring this with me.